I'm
Okay.
sure you'll be fine.
So to do a hello world smart contract, like what's the first thing you need to do? Like when I say hello world, I mean like actually making a contract, deploying it, and like testing that it's valid. Like that's what I consider like hello world, where like you could call one attribute on it and like verify that it gives you the result that you wanted.
Yeah.
Like what's the first step?
Well, okay. So I'm sure we're going to go through it here right now, but
Yeah.
I would say the first step is go on to the Ethereum Foundation website and go through the Hello World tutorial.
Okay.
And go through the series of steps that it recommends, and you do exactly that.
Like this, right?
Ethereum or
Yeah. Oh, gotcha. So what is Ether? Learn the Solidity language, documentation. So just start here, basically.
yeah, absolutely.
Okay. Cool.
Yeah, there's actually a series of pretty good tutorials on there that, I think they're a good starting point. It's always easier to go through something with another person kind of guiding you. It can be kind of intimidating to just go to a web page and try and figure everything out on your own.
Yeah.
Which is something that I experienced many times.
Yeah, I'm sure you're banging your head against your computer for about 6 months before you finally got your head around it.
Right, but fortunately, the documentation is done pretty good, and there's a lot of people working on developing this stuff full time, making it easier for people to pick up. So
awesome. Okay, cool. So given that I've already gone through the Hello World tutorial, but assuming that I didn't, what's the first thing you'd recommend someone did to like actually get started? Like what configuration would they need, or just should they just open up their text editor and start coding like immediately? Like how can you just get and deploy a simple thing just so you know you have the workflow down, and then you could get into like actually the patterns that you use to develop the contracts?
go use the Solidity online compiler. So
Solidity online compiler.
Right.
I actually think I have the compiler installed locally, but I'm assuming you mean this thingy, right?
Right.
Okay.
Yeah. And so click the top link, and it'll take you to the most recent version.
This thing.
Yeah.
Okay.
And so what this is it runs in your browser. It compiles your Solidity code in real time, and you can simulate deploying contracts, and you can set values in the contract or query values in the contract. And it's like, if you're trying to do like a full scale, like, create like an entire platform with smart contracts, this is not the way to go. But if you're trying to basically become familiar with like very simple contracts, then this is the place that I think is really easy to start.
Okay. So can we make a simple contract in this and see what all the different thingies do?
Yeah,
all
absolutely.
Right. So what's like the simplest contract you can write? Is just contract. Oh, so this also like lints it for you? Like it'll tell you when there's an error?
Right. Yeah, it has a just-in-time compiler.
That's pretty cool.
Yeah, it's really convenient.
And this is compiling Solidity into the Ether script, that like assembly kind of language.
Correct. So you can. So as you write your Solidity code, you'll see on the right side of the screen there is the bytecode. So the compiler compiles Solidity into bytecode, and that bytecode is what is eventually deployed onto the network.
So this.
Yes.
This is the thing that you would be deploying.
Correct.
Wow.
Yeah.
That's crazy. And it can take a huge contract and put it down into like a few lines of this, basically.
The bytecode can be pretty big. So if you have a big contract, the bytecode might, sort of be proportional to the size of the contract.
Okay.
So yeah, there's basically just like a few things that you need to know about a smart contract. If you have your smart contract written and you want to know what to do with it, well, you're going to compile it into bytecode. That's what you deploy onto the Ethereum blockchain, and then you have an interface, and the interface just basically shows other smart contracts, or let's say you have an application, how to interact with that contract that you've deployed.
So like all the different functions you could call on it is in some interface that's also part of the contract that's deployed.
Right. So if you write a smart contract, you deploy the bytecode onto the blockchain, but you don't have the interface.
Right.
You can't interact with your smart contract.
Gotcha.
You have to know what goes into your functions, what comes out of your functions. And
gotcha. Okay. So what's what's the simple like hello world contract? Like, can we put a value, just a static constant value, and then a function to just query for that value?
Yeah.
Okay. So
I mean, what do you? We could just
make a value called balance, which is a number, and then let's just make a function that's like get balance. Okay. So uint balance, you're declaring a variable of
now
type uint.
Right.
What is a uint versus an integer? Like, why is it uint?
So an integer is just a number that can be positive or negative. It's an integer value.
Okay.
An unsigned integer, uint, is an integer that can only be positive. And so I forget, the maximum value that a normal integer can take on, but it has a maximum value and then a corresponding minimum value that's a negative and mirrored value. Essentially, what an unsigned int is it's just shifting that range of values that the integer can take.
So it can be higher numbers if it's a uint versus an int, because you know that it's not negative, so the same. Okay,
but there's actually no such thing as an int in Solidity.
It has to be positive or negative?
Well, as far as a data type goes, you can have negative values, I guess. But,
oh, okay.
Yeah.
All right, so we have a uint balance, so that's just declaring the variable. And then I've seen these things that are like constructors, I guess, that look kind of like that.
Right.
So I guess you do like this.
Right.
So this is like a thing from like Java, right? Where it's like you write the same name as the contract with no parentheses, and that's a constructor function.
Right, yeah.
And just so you know, you're on that keyboard, I'm pretty sure the Alt key is mapped to the command of like the Mac. So
okay.
Yeah.
Yeah, so the constructor is just a function that is run one time, and it runs automatically once you deploy your contract to the network.
Okay, gotcha.
Yeah.
So it runs on deploy and then never again.
Correct. You can't call on your hello world function after deploying it.
And this is where we would do some sort of initialization. So can I just do balance equals 1000?
Yep.
And then that's setting the value. Okay, so I guess we'll get into the concept of gas at some point, but do these constructors cost gas to run?
Yeah, so every operation costs gas to run because essentially you have thousands of computers nodes all over the world that are running the same code, and doing anything on 1,000 nodes is pretty costly. So generally doing computing is like, say for example, if you want to do an addition or a multiplication, that's not as expensive as, say, storing a piece of data on the blockchain.
Right.
So storing data such as setting the value of your state variable that's much more.
So how can you understand? Is this online compiler going to give us something that like shows us how computationally expensive this would be and how much vaguely you would need to pay to execute these kind of things?
Yeah,
but
you can do it right now if you press create.
So if I created this contract, but there's no way to get the value, right?
Not yet, but
okay. But if I just do create,
you can see how much it costs.
Wow!
That cost.
Yeah. So that's a cost to transact it to the blockchain,
right?
And then this is a cost for the constructor to run. Like, what execution cost is there?
So it generally costs around 20,000 gas to set a value.
Oh, gotcha.
So if you have like multiple state variables.
But if we didn't do that assignment, now our execution cost is like nothing. It's 2,000. But if I do set that and then hit create, now it's 20,000 because it costs 20,000 to do the assignment.
Right. So generally, like I said, generally storing data on the blockchain is more costly than running sort of computations because thousands of computers all over the world have to store this piece of data. So
that makes sense. Yeah, so it's like a huge minimization problem of trying to minimize your computational cost. All right.
You want your contracts to be efficient.
So how could we write something in this to get the balance where we could call out to this contract and view the current value of the state? And then I think that's the simple hello world that I would.
So it's actually really nice how Solidity is set up. You can define different, I forget what the term is, but you can have like public or private state variables and functions. So, and that will
So a public variable would mean that I could just call out to that contract and get the value without having to spend money.
Right. So they're called, yeah, I mean, an accessor. An accessor is automatically created for every public variable.
Okay.
And generally functions are set as public by default. So.
Okay. Okay, so this is then hello world. I should be able to deploy this to a blockchain and see the balance is 1,000.
Right.
It's like a simple hello world function.
So you can deploy it, and if you have the interface to this contract, then you can call,
okay.
You'll know that there's a balance.
So what's the simplest way to set up like a test network to deploy this against?
So
what do you recommend?
TestRPC.
Okay, so I have that downloaded.
Yeah.
So what exactly is TestRPC? I know that you can run it by literally doing this, right? TestRPC.
Yeah, that does it. So TestRPC is essentially a simulated blockchain that runs in memory on your computer. So there's no mining. So on a live network, even like the test network, the Morden test network, which is live, every transaction has to be included in a block, and that block has to then be mined. And so let's say if you're doing a series of different transactions, say you want to deploy a contract, and then once it's deployed, you want to interact with that contract, it can take a long time to go through that series of steps, 15 seconds for each block.
So deploying in RAM is just so much faster than on a live network.
Correct.
So so just to get this straight, Ethereum has a live test network.
Right. The Morden test network.
Don't worry about that. So there's a live test network that says, okay, there's real people around the world all sharing that test network with live. This is just the local host, essentially, where it's only locally on your computer and it's faster. Okay, exactly. Cool. So when I do TestRPC, what wallet does it think I'm logged into? Because it gives you these private keys and public keys, but if I send a transaction to it, which account does it think I'm sending it from?
So I think by default it sets your default account to account 0.
Okay.
Yeah, and these are all just randomly generated accounts just for testing purposes.
Okay, so this is a private key, this is a public key, and if I deployed a contract against this, it's just going to assume this is the thing that I'm doing it from, but I could set it to be a different one of these if I wanted to test a transaction sending data to each other.
Yeah, absolutely.
Okay, cool. All right, so I've got this thing. It compiled it in the browser, and how do I deploy it?
Well, so there's a few different options. First option is that you could deploy it directly from the Solidity real-time compiler
to my TestRPC
right here in the browser,
or it has its own TestRPC that you could.
Well, it has. Yeah, I'm not sure if it's TestRPC. I would assume that it is actually though. Yeah, where you can basically run transactions against your contract. So if you click create right now.
Okay.
So now, yeah, I mean, essentially this Solidity real-time compiler, has this contract that's deployed in memory, and it has this balance variable, and you can interact with it. So if we were to create a function in this contract, we would be able to run that function.
Oh wow! Yeah, I see that it shows what the state variable is here.
Correct.
So this hello world at X, this address that it created is the public key, or it's the address rather of the contract.
Correct.
So I would need this if I wanted to call this from another. When you deploy a contract, you need that address basically, right?
Correct.
Yeah, that's kind of the workflow that I'm having, that I want to just wrap my head around better, is when I deploy a contract, how do I then later call on it? What's the actual steps for that, I guess? So okay, so I see this here. If I wanted to deploy it locally, could I what would I copy and what would I need? This thing or the bytecode?
If you want it, yeah, you would need to have the bytecode and you would need to have the interface.
Do you know how you go about doing that? You said I know you mentioned Truffle as a tool. Would that be what you would use to?
You would want to use Truffle. Okay. So with Truffle, you don't have to worry about compiling your contracts and then getting your bytecode and your interface and storing those, and it basically takes care of all that annoying stuff for you. So you can just have your Solidity contracts, and you can write Truffle compile, and it will compile all your contracts. If there's dependencies between them, it will automatically link those contracts.
Gotcha. So when you're doing more advanced contract development, you're going to want to use a tool like Truffle because it deals with like your dependencies and stuff.
Absolutely. So I only recommend the online compiler, like the in-browser compiler. Just it's a great way to like quickly get started. You can like just type up stuff and you can see in real time if you're writing in, something that like throws an exception in Solidity.
Sure.
But if you want to create any sort of like large scale project that has multiple contracts,
you're gonna use Truffle.
You're gonna use Truffle.
All right. So how would I do? So say we want to do that same Hello World contract in Truffle. Would I? Do you make a Truffle project like by doing Truffle
init initialize
and then some name of it, right? So we'll call this just.
You don't have. I mean, you
just Truffle in it. All right.
Yeah. So you create a new folder and you can.
Oh, you do Truffle init inside the folder.
Correct.
Yeah, I did that on my desktop. That's probably not the smartest.
Yeah.
All right, let me roll that one back real quick.
Right, so you're going to want to create a new folder, and the folder is named after whatever you want your project to be named.
Okay, so I will make a folder called Ethereum, and then cd into it, and then I'll do Truffle in it. So now this is a Truffle folder, basically.
Right, now you have...
It's weird. Their generator should make the folder for you, just in case any consensus people are watching this. But now I could open this in a text editor and look at what it generated. So Truffle init, what do we got here? All right, so we've got app, contracts, migration, test, Truffle test. This is like the config thing, right?
Yeah, this basically, you can configure it to run on, you can have different test blockchains. You can, and I believe this. So yeah, this is where you have like your app files. So if you have like an application, like a front end JavaScript.
Oh, gotcha.
Yeah.
And then this RPC is telling it when we run Truffle, use the localhost TestRPC as your backend, so to speak.
Correct. So that's your blockchain.
Okay, got it. So that's configured there. Then it has some default contracts, it looks like. But this is where we would put the actual contract for our hello world, right?
Yep. Yeah.
All right, so let's try it. Let's just copy what we did here. And then do contracts hello world.sol. Yeah, I have it has like the color highlighting for Solidity, which is cool. Nice. And okay, so I made this. So how do I deploy this to the testnet?
Well,
like a real dApp developer.
Okay, so
I guess.
So first, you're going to want to go back to your command line, and you're going to want to run truffle compile, and that's the first step. And what that will do is it will compile all your contracts, all the contracts in your contracts folder. It will compile them, and it will create basically, they're called artifacts, but essentially they're like JSON files, I believe, and they contain the bytecode and they contain the interface that.
So that lives in this build, basically. Yeah. So it makes... Oh, wow. Yeah. So it makes this, basically.
Yeah, it's not JSON.
This complicated, scary thing. This looks like... Yeah, so this is the binary, I'm assuming, is this thing here.
Right.
All right, cool. So it makes big, scary file that I don't need to look at.
Yeah, but essentially... So you don't need to look at it, but... So what that file is going to do is it's going to allow you to very easily just interact with your Hello World smart contract without having to do anything hairy.
Okay.
So in the future, it's going to make your life way easier.
So we compiled it, and then if we want to deploy it, is it just Truffle migrate?
Truffle migrate. So migrations.
Yeah.
Awesome.
So what exactly are migration? I mean, I know what migrations are in a database sense, but in a kind of contract blockchain sense, what are they referring to when they say migrations?
So migrations are. So I guess I would say they're sort of like scripts that go through a series of steps that you want to go through. So let's say it's not the best example if you have one smart contract, because it's very easy to just write, all right, I want to deploy my contract, and then I want to query the balance variable. But if let's say you have a larger scale project and you have a bunch of different contracts, and say they have different dependencies, or you want to set them up in a way where they have sort of like dummy data, so that you can kind of get a feeling for what your application might look like once people start using it.
Gotcha.
Then migrations allow you to kind of just automate the series of steps that are needed to deploy your contracts, set them up in the way you need them to be set up.
So they're like build scripts the way like Chef or something is like
Yeah.
a build script for
Yeah.
like DevOps or something. Okay, gotcha. That makes sense. And then do you need to configure anything, or by default, if I do Truffle Migrate, will it know about that Hello World contract that I just added? Or do I have to like add it to some array?
It already knows about it, but what you do need...
Yeah, what is this thing? Deployer that has...
So okay, so migrations are relatively new. Truffle got updated recently, but so essentially you have just a few different JavaScript files, and each one's a migration, and you kind of want to set them up in sort of like a sequential order to carry out different steps.
Gotcha. So if one is like a dependency of the other, you want to migrate that one first, basically.
Correct. Yeah, and so we don't need to get into it too much, but essentially the Truffle also creates a migration smart contract, and what that will do is that'll keep track of which migrations you've run up until now. So like let's say that you have already deployed all these contracts and stuff to to a live network, and you want to run further migrations, it will know that it already ran.
So it'll actually have state stored on the Ethereum blockchain that knows about your dev environment, essentially, like which migrations you run.
Which is kind of cool. It's a new concept for me. But
it's fucking crazy.
Kind of
all right, so if I just hit Truffle Migrate, this Hello World thing will get transacted.
So what you need to do is you need to go into the second migration, deploy contracts,
and add this.
And what you need to write is deployer dot deploy.
I can. So if I comment, what is the auto link thing? I get what this means and what this means, but what is this thing?
So in the example project that it's included in a default Truffle project. There's basically two contracts. One of them is called a library contract, and the other one's just a conventional normal smart contract.
This guy.
Right.
So what is this? What's a library? Yeah.
So a library contract, it's basically like let's say that you are going to want to do this a certain operation, or execute a certain function very frequently, and there might be 100 different contracts that want to execute this function. Instead of having to include 100 of these functions in each individual contract, which is costly, remember,
right?
Because everything you put on the blockchain is costly. Instead, you can deploy one library contract, and all of your smart contracts that need that function can just refer to
and conceivably somebody else's smart contract also could use that library contract.
Right. It would need to know the address of the contract, and it would need to have like an interface.
So the idea is that if there is a common computational task that you do frequently, it's actually better to abstract that into a library and then reference it from your smart contract.
Yeah.
Oh my God. That's crazy.
It's really cool.
I feel like I'm going to say that about 100 times learning about Ethereum, but that's crazy.
Yeah, it's really cool, and it's kind of neat because it's still early days, but eventually, I think that what you'll be able to do is you'll be able to go online and you'll be able to look up a bunch of just public libraries that other people have put onto the blockchain, and you'll be able to use those in your smart contracts.
Yeah, that's awesome.
So that's great. Yeah.
Okay, so we added that line. Finally good to do Truffle Migrate. It's nerve-wracking. All right, so something happened.
Deploying Hello World, and then...
So the first thing, that migrations, that's the thing that you were saying, that's the state where it now deployed this, so it knows about which contracts we've deployed and which ones we haven't.
It deployed the migration contract.
And then it deploys our Hello World, and it gives us a hex, and so this is the address of the contract.
Correct.
All right, but... So I'm going to copy this, but apparently we don't need this, right? Because the way that the Truffle... Okay, so if I do Truffle console, that's what you would do to start inspecting this?
That's one way to do it, yeah.
Oh, what would be the other way?
I think Truffle console is good.
All right, so this is just some JavaScript console, right? We're in JavaScript land here.
Yeah, maybe. I haven't used the console too many times.
Yeah.
But yeah, so now you basically have this nice Hello World object. Hello World.deployed. And
oh yeah, you missed here, I gotcha.
So this will Hello World.deployed will always refer to, assuming you have a single Hello World smart contract that's deployed, onto your blockchain, test blockchain, live blockchain, doesn't matter. You'll have this hello world dot deployed that it's an object and it refers to everything you could possibly need to interact with or refer to that smart contract.
Gotcha.
Which makes it really easy to do things like create like front end applications that interact with your smart contracts and stuff like that. So.
Wow. Okay. So this is just part of the Truffle dev environment. Knows about this contract. Makes this hello world dot deployed. So we could set this to a variable called hello world, right?
Yeah.
So now we have this hello world object. So how would we get the balance? That was the.
So you would go. So I'm assuming we have our hello world.
Yeah, we have that.
It depends. So like.
Yeah. Oh yeah. So this is a promise. So that we could. Yeah. Just Java. So yeah, I'm pretty confident at this point that this is JavaScript because that just worked. But
so you'll see. So what are returned is a promise. So it's basically waiting for a callback. And so this is a very important point that every transaction that if you send a transaction out to the blockchain, you can't just instantly get a response. You have to wait for it to be included in a block and for that block to be mined.
So the promise object returns after the block is mined when you make a transaction. So like basically if I submit something to the Ethereum blockchain, it's going to return a promise, and the promise will return after the block is mined if you're submitting a contract.
Right. So if you go, I think it's a pretty straightforward example of how you're going to interact with these promises.
Okay.
If you go to your Truffle project, and then you go to tests or test. There you go.
Okay. Metacoin.
So this is the metacoin one.
Oh my god.
Right. So
maybe just the font is big. Maybe it's not actually that bad.
Oops. I don't have a mouse. Can you go back to the?
Oh, I could get you a mouse.
No, it's fine.
What is it? Which one do you want to?
There you go. Yeah. So what they're doing here is it's sort of what we would want to do with our Hello World contract. Is actually exactly what we would want to do with our Hello World contract. Is they're just querying the state of the balance, and the what you see for this like call and then in parentheses accounts part. So there's two different types of basically ways of interacting with the blockchain. There's you can execute a transaction, and so a transaction is something that changes the state of a smart contract or changes the state on the blockchain.
Gotcha. Okay.
And that requires the network to basically mine that in a block and update. It essentially changes the state of the blockchain.
Sure.
And then there's also something called a call, and you're not changing anything with a call. You're just querying data.
Gotcha. Okay. Sure. So I guess that that's something I didn't even realize. So a call is a query. It doesn't change state. Returns a constant value. And then, so can a call, okay, so what if you're not changing state, but you still need to do computation? So what if you have a function that returns like x times y?
Yeah.
And then you call that. So it needs to like...
That's free. You don't have to, there's no...
Because they can statically figure out what the value of that would be.
Right. So like assuming, let's assume that you're running a node. So you have the entire blockchain in memory. And you're doing a call that needs to run some series of steps of computations. Your computer is just going to run those computational steps. The entire network doesn't even need to know about you calling on that.
That makes perfect sense. Okay. So a call is a call, and a transaction modifies state.
Right.
So we're not modifying state here. We're just querying for the static value, which is why we can do this call.
Correct.
And then log it. Okay. So what's this object we got back? Because this is weird format, right? For like a number.
No clue. I don't even know. I haven't gone that deep down the rabbit hole.
But I'm assuming I could just do this. No? This is so weird. Okay, but whatever. So I'm assuming just whatever is in that C thing is the value, and it looks like a string comes back. So, all right. But it looks like it knows at least that it's 1,000. So there was some way to call out to the chain, get our value back. All right, makes sense.
Yeah.
So then the level 2, I guess, is then can we put a function that can change that number and then query for it? That would be level 2 of this contract. So like balance is 1,000. You could have some number like deposit that just increases the balance, and then we call out to it. And then this would be the other example where you're saying a stateful transaction as opposed to just a static query.
Yeah. We can put return uint, and we can put it as a new value.
Okay. What is the? I see this sometimes where it says like constant returns or returns constant. Is that something you need to specify, or is that like optional?
So that is actually what will differentiate between a transaction and a call. So a constant function does basically what you said. It will query something. It will query a value from your contract, and it can run computations on it, etc. But it won't change state. So yeah, if you have a function that doesn't change the state of the blockchain, it's a function.
So you're not returning constant because this will vary every time. You only return constant when it's going to be. Okay, makes sense.
Right.
So we're saying that this takes one argument of type uint, which is value, and it returns one argument of uint, new value. Got it. So this will just be balance plus equals value.
Yeah.
Right?
Yeah.
Oh, wait, hold on. So I would do balance plus equals value, and then I need to return balance. Is there implicit returns in these functions? Like, will it return the last value the way JavaScript or something would, or do you always have to specify?
Yeah, your functions don't have to return anything.
But since we specify that this is returning an int, we have to return the int.
Correct.
Okay.
Yeah.
So return
balance.
So that's safe. That's going to cost money because we did a computation.
Right. So that should cost around 20,000 gas.
20,000 gas? No, I have no idea how much that is.
To update the balance, it should cost around that, and then a little bit of extra gas just for, I don't know, housekeeping stuff.
Okay. So balance plus equals value, return balance, and then we should be able to just query the value balance the same way we did. We don't need a function for it.
Correct.
Okay, cool. So, all right. So we already compiled this contract and deployed it. Can I just do that again? Like, well, it'll know. So if I do truffle compile and truffle migrate, it'll know because it'll compile it. It'll be like, oh, this is different binary. I should redeploy that.
Right.
So truffle compile. Oh, Grant says my stream died. It'll come back. It'll come back, Grant. All right, so it didn't look like it migrated it though.
I mean, I think if you just did it as truffle compile and wait for it.
Well, like it should have given us, or maybe it just doesn't. I wonder. Or I wonder if you have to. I wonder if you have to reset it. I think I remember having to do that once.
Yeah.
Where you do -- reset and it'll reconfigure it. But okay, so if I do truffle console. And then I do the same thing, var hello world equals hello world dot deployed. Got that.
Right.
Dot balance dot call. Dot then console dot log. 1,000. All right. So now I want to update, or I want to deposit something. So how do I call that?
So you would take a similar approach where you instead of let's just do it. Let's see, deposit.
So you just call the function the same way you would think to.
So let's put 500 whatevers into our balance.
Right. These are just arbitrary numbers.
Right. And so typically, our deposit function only takes one input, and that's a uint. But what you can do with Truffle when you're interacting with your contracts is you can specify which account is sending a transaction.
Oh, okay. So if I go to my TestRPC, scroll back up. So what would you use the public key? Like if we wanted to have number 1, this guy.
No. So okay. So I believe by default, let's actually get rid of this now.
Okay. Web3.f.accounts is probably. I think you're probably looking for that, right?
Yeah, there you go.
Yeah.
Okay. So I guess we can create.
Yeah, no, that keyboard kind of sucks. I have my mechanical keyboard, which is awesome, but it's so loud, like it's impossible to record with it. Yeah.
So you can also do, I believe it's like web3.eth, like default account or something like that. But
Okay.
that's the first account.
What is .coinbase? I don't know what the hell that is. Get accounts? Yeah, whatever. I don't know which one it is. Oh yeah, you're right. It was default account. You had it. Default account. Oh, I guess it doesn't have a default account. You probably have to set it.
Yeah, maybe so. But yeah, so essentially what you can do is
okay, so
if you're interacting with your contract that's been deployed with Truffle, you can basically set which contract is sending that transaction. So that could be important. So for example, if you have, let's just say you have 2 accounts, and one of them has some Ether in the account and the other one does not, well, then if you're doing any sort of transaction that requires Ether, then you need to send that transaction from the account with Ether.
Gotcha. Okay, so we need Ether to do this transaction, is what you're saying. But
well, to do any sort of transaction, luckily for us, we're using TestRPC, which it just gives you a bunch of accounts. And
so can you check the balance of the account?
Yeah, I believe so. Let's see, web3.eth get balance. Yeah,
oh, gotcha. So it just put a lot of this Ether into.
Yeah, it's all fake Ether.
Yeah, gotcha.
That gives you a bunch.
Okay, so this is probably our default account. This one. So if we wanted to call into it, we would do hello world dot deposit, and then let's
whatever
say
value you would like.
Okay, so 500 we did before. So just calling this will actually call it.
Yeah, but that'll return a promise. So then you have to catch your promise,
right?
And you can,
So this would, in theory. Oh, so yeah,
this
then
returns
it returns
a transaction ID.
Yeah.
So.
And if I check this balance, this should in theory be down, right?
Yeah.
Yeah, look, it's less. So it actually cost Ether from that account to do that.
Yeah, it cost.
So we call deposit, and now if we call, which was it? Hello world.balance.call. 1,500. There you go. Right. Stateful transaction. Well done.
Yeah. So I mean, you can see there's more going on here than we're trying to do a very simple thing. We're just trying to increase a balance, and essentially we'd like to have one number that then changes to a different number.
Yeah.
But there's more going on here underneath the surface, and that's these are the things that make life easy. That Truffle has done to make life easy for us.
Gotcha.
Yeah.
All right. Cool. Okay, so that's how we made this awesome transaction that could do some sort of stateful thing. So now it starts getting out of like hello world and into more like real stuff. If we said, for example, I want to have multiple accounts in this contract that each have their own balance, and then I want to transact to a specific account. So this is basically building what you'd call a metacoin, right? Which is like a virtualized currency on top of Ethereum. And this is what I got to this point where I was like, okay, now I don't really understand it anymore. So I don't know, like, I think it's straightforward, I guess, from yeah. So like if you could like, talk through how you might go setting something like that up where you need to have kind of a little bit more complicated data structures.
Right. Yeah, absolutely. So actually, I think this is probably one of like the most important smart contracts that is available right now. So basically, the Ethereum Foundation and the developers and the community came together to form something called a standard token contract. It's the ERC20 standard token contract, and essentially, essentially what it is, it's just like a very generic token that stores user balances. So you can have a bunch of different accounts, and each account can have a unique balance. And then the smart contract includes a few different functions that allow users to transfer their tokens to other people. And these tokens can represent anything. They can represent shares in a stock, like ownership over equity in a company. They can represent game tokens or some sort of scorekeeping. They can essentially represent any sort of value transfer system.
And this was what the DAO was. They had a DAO standard token that represented a share in an organization.
Correct.
And then this is what people are doing with crowdfunding now, where it's, I want to have tokens represent equity interests in my business, and I want to be able to distribute them.
Right.
So I guess you'd call this a standard token contract.
Standard token contract. It's like it's one of the most fundamental building blocks of like. I really think it's going to be included in most large scale applications that are built on Ethereum. So it's really important to understand how the standard token contract works.
Okay, cool. So in order to store the state of these standard token contracts, you need something resembling a hash map, which is like the most integral data structure to doing any kind of programming.
Correct.
So what's the Solidity way to do that?
So in Solidity, this is called a mapping. And mapping is essentially, it's like a hash table. And you can map from any sort of any data type. So it could be like an address, which is probably what.
So an address is just that string hexadecimal, but that's just a native data structure in Solidity?
I believe
so.
So.
Okay. So it's called an address. Yeah, I gotcha.
So we can make a mapping that maps from addresses, so different wallets or different accounts rather, to a uint, so to a balance value. Balances.
Okay, so now I guess we could get rid of this just to clean it up for a hot minute. All right, so we have our hello. I guess we're not even hello world anymore, whatever, we'll leave it like this. So we have mapping of address uint to balances.
Right.
Now, in theory, we're going to need to create a contract from an account that is like the admin, essentially. Like because you'd have the ability to figure out how many of these virtual coins exist, and like I assume they all go to the admin to start, and then he distributes them.
Yeah, that's correct. So I mean, we can code it up here, or we can look at
let's code it.
Existing template. Okay.
I think it's easier than than taking the template. So
okay. So you're saying you basically when your contract is first deployed, you want the person that deployed the contract to be essentially the admin.
Yeah, exactly.
Okay. So this is a really common pattern in Ethereum smart contracts. So essentially, you want to have an owned contract. And so there's a few different ways we can do this. I think probably the best way to start is to just do it this way. So what we're going to do is we're going to create an owner state variable.
Okay.
What's up, Lucas? Public address. This keyboard's giving me issues.
Yeah.
Owner. So this is just a public address, and what we're going to do when our contract is first deployed is we're going to set owner equal to message sender.
Okay, so what is that message object?
So there are a few things that are just built into Solidity that are kind of nice. They make things very convenient for you. One of those things is message.sender. So what message.sender is it just takes on the value of the address that is sending a transaction.
So when this is compiled, Solidity will replace that thing that says message.sender with the actual Ethereum address of whoever sent the contract.
Whoever, so upon
or sent the transaction.
Upon deployment of the contract, it will,
or the transaction. Just message.sender means whoever's calling that contract.
Correct.
Gotcha. Yeah. So we're just gonna on the init take whoever deployed the contract and store that as owner. That makes sense.
Right.
And then I guess we would give that person in the hash table a starting balance.
Yeah. So what we can do is we can say balance is owner, or we can say message sender, but we'll just do owner for now, is equal to 1,000, call them just metacoins.
Yeah. Okay. So he's got the metacoins. This is that. And then how can we check the balances? Because can you access that mapping the same way we access the uint beforehand?
You cannot.
Okay. So you can't just call out to any hash map value.
Well, yeah. So what you can.
But I mean by default, like from the console, or do you need a function that does it?
No,
like,
you need a function that does it.
Gotcha. So I mean, like, it's not that same thing of like that public variable. That
right. Yeah. It doesn't work that way. You have to have an accessor that essentially will, query the balance of a specific input address.
Okay.
Right.
So yeah. So we'd make a custom function for this.
Yeah. So we'll create a function called getBalance, and then we'll put address, and we'll just call this user constant returns.
And when you put the word constant, this means that you're able to query it. If you didn't put constant, you wouldn't be able to call this without using gas.
Yeah. So essentially, the constant just tells it just says that this is a function that does not change the state of the blockchain.
Okay, gotcha.
So and then we'll put balance, and then we'll put return balances user, and that's it.
Okay. All right, that makes sense. So it's essentially doing the public accessor, only because it's a mapping, we need to write this function that does it for us.
Right. So yeah. So a hash table essentially, So specifically for a mapping in Solidity, every single possible address. So we're doing a mapping from an address to a uint. So every possible address is initialized to 0, 0, 0, 0, and then every int is also initialized to 0. So where you might be used to having a hash table that only has entries that have been specifically put into the hash table, a mapping is different in that it automatically has initialized 0 values for everything, and then you just modify those 0 values for.
So what that's essentially saying is that there's no way to really loop through this. There's no concept of hey, let me just loop through the keys and values and see what's in there.
You cannot loop through this.
Yeah.
But there's some nice block explorers. So let's say you're just interested in looking at
what addresses exist.
Yeah, there's a bunch of accounts at a contract that you're interested in. This contract's already deployed on the live network and stuff. You can go to a blockchain explorer and ether.camp, and what that does is it will actually list out all of the key value pairs for mapping for you.
Oh, so if this transaction existed, I searched for it and it had a mapping, I could then look at what accounts exist just in this blockchain explorer kind of thing.
Right, because it contains the whole history of the blockchain.
Gotcha.
It can it just accumulates all the
cool.
entries if they
that makes sense. All right, and then how would I send a value from one address to another? Then I assume we could deploy this and it would work. I would rather, let's take it one step now to the future, which is I want to code the function that lets someone send money to each other.
Yeah. So we would create a function called transfer, and we'll put address, to,
right,
and we'll put uint value, and this is not constant. Return.
And we would have message.sender as a variable.
Right. So we know by default who's sending this transaction.
Okay.
So
So we do something like balances message.sender minus equals value balances 2 plus equals value. That's the idea, and then you do some sort of check here to make sure that 2, or the message.sender has that value. Yeah, so how do you do conditional logic in this? Like, can you just do if statements the way you would?
Yeah, it's set up to be very familiar. So you could just do, you know, balances, message, sender, let's see.
Or so if it's less than.
If it's less than value.
Yeah.
Huh?
No, I was saying I missed the underbar there. Thanks.
You can return false, and you know, if this isn't true, then you go through the transaction. You return true.
Gotcha. So once it returns your return, so you just have a little check there that's saying if they don't have the value, return false, and if they do, return true. Okay, cool.
Yeah.
So that's the transfer function. All right, and now we can get anyone's balance. So yeah, so we should be able to deploy this and test it out. Let's see how we did. Exit, truffle compile, and truffle migrate -- reset.
I think it could be worth going through the standard token.
Yeah.
After this.
Okay.
We're kind of going through it already.
Yeah,
but
I'm down. I'm assuming, is that what this metacoin thing is? Is this? I'm assuming this is the standard token, or?
It's actually not. It's
different.
It's similar. It's just an example. The standard token it's like really well thought out. A ton of people.
Okay. Yeah. I'll take a look at it. Interesting. Why isn't this deploying?
TestRPC still running?
Yeah. All right, it worked. It just took its sweet time. I'm assuming we're gonna need. Oh no, we had that accounts variable in this anyway. So okay, so truffle console. Starting to get the flow. Var hello world equals hello world dot deployed. Got my contract there. So we have that web3.f.addresses. .address. What was it?
Accounts.
Accounts, sorry. Right, so this is account 1, this is 0, this is what it uses by default. So we'll do account 1 equals and then we'll do account 2 equals accounts 1.
Cool.
Okay. So we have hello world. So the way I would think, so we can do hello world dot transfer. Well,
this is great. Actually, this is really good because what you're trying to do, is exactly what Truffle makes really convenient and really easy.
Because it can sign the.
Essentially, what you're trying to do is you're trying to write a test. You're trying to say, let's see if I send, coins or tokens from one account to another,
Sure, it's manual testing opposed to automated testing.
Right.
Yeah, but you're saying you can write automated tests that can do this.
Right. In fact, the default test that comes with the metacoin project by default
will test the transfer function.
Right. So they have a similar function, send coin, and.
Okay. So just to see, so we have hello world, and in theory, I should be able to do get balance of the default address, which is account 1.
Yeah.
Like this.
Right. So this is the owner. This is the.
This should be 1,000.
This is the account that deployed.
Oh, sweet. Yeah. So that's 1,000
contract. Right.
And then if I did account 2, it would be 0. Because you're saying this already exists in the hash map. It's just initialized to 0, which it is. Okay, cool. So things are logical so far. So hello world dot transfer to account 2. Let's do 25.
And it's important to note that right now, you're sending this transaction as account one.
Yeah.
This is by default.
Right.
But if you were to try and send this transaction from a different account that did not have a balance,
it would error.
This would fail.
Oh yeah, we could take a look at that too. Like we can make an account 3 also. But this should work. And now if I get balance of account 2, 25, account 1 is 975. So this seems to work. And then if I did an account 3 and then tried to transfer from, well, okay, so let's just try to transfer something that we don't have, which is, let's say, like 10,000, right? So this would error then.
Actually, I don't think it would, because we didn't check if you're sending. Wait, did we?
Yeah, we checked if the balance is less than value.
Yeah, we did. That would fail.
So then if I tried to get the balance of account 1, it's still 975, and account 3 would be 0. So it just never went through. Right. So we did have some check in there. It just cost gas to even try, basically. So we just wasted our time.
Right.
Okay, cool. So yeah, so what were you saying about the standard tokens? Can I just Google for this?
Yeah, you can. ERC20 standard token.
So ERC20 standard token.
That's it.
This guy?
Yeah. So essentially, this is just a, it's a smart contract. It's a very simple one that a bunch of people, thought about how to best structure a token contract in a way that, it allows tokens to be easily integrated into applications. All tokens behave the same way. You don't have all these different proprietary tokens.
And this is all open source.
This is a community project.
Oh, that's great. Star. Well. Yeah, that I'm going to need to look into. I'm very fascinated by that.
Right. So a standard token, essentially, it does what we just did, and it does more.
And it probably is better, more robust error checking, and kind of things like that.
Yeah.
Okay, so I guess my next question, and that's probably the extent of it, is just then how you kind of deal with iterating through data structures and looping and things like that. Because I'd imagine if you did want to store all the known values of your, say you wanted to make a web UI for this kind of thing, it would be really helpful potentially to have just a static endpoint you could hit that just showed you all the different accounts and their balances. So I'm assuming you'd need to essentially cache that whenever you create an account, and then you'd have some sort of array data structure. But you can't really do, from what I understand, these kind of, you can't map arrays and loop through arrays. It's kind of hard to do that, right?
Yeah, I mean, well, you can, but so one of the issues with loops, for loops, while loops, and stuff, every computation costs gas, and
so each cycle of a loop would cost additional gas.
Correct. So if you really poorly designed smart contracts, might do something like pay out a series of users in a for loop, and it could be like a gambling application or whatever it is. And the problem with that is that if your application gets popular and a lot of people are using it, eventually you're going to run out of gas when you try and pay out all of your users.
So you would need to try to pay them all out at the same time, kind of thing.
Well, actually, so I think generally the approach that you want to take is instead of having the owner of the contract or the admin pay out all of the accounts, iteratively, what you want to do is you want to set up your contracts in a way where each account must go in on their own and redeem their, manually get their payout individually, kind of thing.
So when they get their payout and redeem it, they get docked for the computational price of that transaction.
They have to pay the gas, but fortunately, gas it's not that much. Gas is not all that expensive to do something simple like
just redeem your, which is just
whatever,
essentially just transferring ether or something.
Yeah, whatever it may be.
Okay, very cool. So, so just from your experience developing smart contracts now, I guess just some high level thoughts, what kind of data structures do you find yourself using frequently, and what kind of maybe design patterns that we didn't get to touch on here do you find yourself using a lot? What are the most useful things?
Well, so I think one thing that's really useful it is the doubly linked list. So you asked, let's say you have a mapping and you have a bunch of different accounts that are stored in this mapping. there's no easy way to loop through all of these entries. And so how can you do that? Well, like a doubly linked list is one of the ways you can do it. You just create this kind of high-level data structure that operates on a mapping. And
yeah, what would that look like? I don't even know what a doubly linked list is. What makes it doubly? What makes it different than a linked list?
It's a linked list.
Yeah.
Yeah. I mean, a doubly linked list. Yeah, it's a linked list where you can move from front to back or back to front through the elements of the list. And so Eris Industries has a decent example of how to implement a doubly linked list.
What are these guys?
Eris Industries, they're creating basically private Ethereum blockchains for enterprise.
What? Look at this CSS.
Yeah, that's pretty cool.
Yeah. All right, sorry. I get distracted easily.
Yeah, it's neat. Yeah, they're essentially creating tools that allow institutions to create private blockchains using the Ethereum virtual machine.
Forget blockchains. These guys should just be UI developers.
Yeah, it's really sweet. So what's awesome? So like this, Eris is not creating tools for the public Ethereum blockchain. They're creating tools for private Ethereum blockchains. But what's great is that they have Solidity tutorials that work. They work no matter what Ethereum, what Ethereum virtual machine you're using.
Documentation tutorials.
Right. I don't. The Marmot stuff's kind of weird.
So these Solidity tutorials are just a good overview of. Gotcha. Modular Solidity, advanced Solidity features.
Right. So
wow.
It's really creating a single contract that does something you want it to do is awesome. But eventually, when you want to start deploying like a platform or a large system where you have multiple contracts and they're interacting with each other, you have contracts deploying other contracts, you're going to have to start thinking about what is your design pattern going to look like? How are you going to, once you deploy a smart contract onto the blockchain, it's there forever. The bytecode is there. You can't change a smart contract once it's been deployed. So how are you going to update your system? Like if you find an error in one of your smart contracts, how are you going to update that without affecting the rest of your system? So I find the Eris Industries tutorials, they provide some really great examples. They provide an example of a doubly linked list, which is great.
So the idea is that a contract could, in theory, call another contract. So you can kind of abstract things to basically say, here's a state variable of the contract you're going to call. And then if I need to make a hot swap, I can then just update that state variable and then call a different contract with updated code. Those kind of design patterns are all covered here.
Right, yeah.
Gotcha. Because that's the stuff I want to start getting into, is like as you get like more in depth into this.
Yeah,
how those kind of things work.
That's necessary if you want to build anything of like any sort of scale. You're really gonna have to have a bunch of contracts that are separation
awesome.
concerns.
Okay, so one last thought.
Yeah.
I'm just curious how you would go about sending, like doing this for real, like either deploying a contract or sending Ether for real. Like what is the different step that goes from what we just did in that TestRPC to like the real world? Because like this is localhost, but like what is the deployment, like just I guess what steps are in between us, what we did and what actually is on the global blockchain?
Yeah, like it sounds kind of crazy, but it's not all that different. So if you want to deploy smart contracts onto the Morden test network or onto the live the live network, it's not all that different if you're using Truffle. So Truffle, you can configure it so that it will, do all. You can set up your contracts
here,
to behave. Yeah.
You would just change out that for the testnet. So the testnet is like you'd run a client with the testnet on the back end. I would just tell Truffle that that's what I'm doing. You
would run a Geth node, probably a Geth node on the test network.
Yeah. So I have a question about it. So if I killed TestRPC there, I have Geth installed, and I forget how you do it. How do you run this on the test network? Do you know?
I think it's like Morden or something. Can you bring up the options?
Geth. I believe this would be just Geth, and then probably dash dash testnet Morden network. This guy.
Yeah.
Olympic. Does this have anything to do with the Olympics, or is that? Okay, yeah. So I do this, and then it's just like it just syncs blocks forever, and I have no idea what's going on.
Yeah, I mean, you have to download the entire.
I think I'm somewhat close though. Like, I don't know. It says I got 1,101,000. Okay, so this is an actual node. So that means my local Mac computer is actually a node on the testnet.
Yeah, and the first step that your
Like,
node has to do is it has to download the entire blockchain.
But like I Google like Ethereum nodes, which like I saw this in like I don't even remember the source of this, but I saw this website Ethernodes, and apparently this lists like every node on the network, and there's only 7,738.
Okay.
Like if I just run Geth on my local Mac, that makes me a node, and now there's 7,739.
Yeah.
Really?
Yeah, really.
So like I would be like 1/8,000th of the entire Ethereum network just by running that command. That seems like not right. Like I don't.
Well, I mean, I mean there's 8,000 nodes, roughly 8,000 nodes.
So are we just like crazy and like Ethereum isn't actually that big and we just live in a bubble where everyone talks about it? But like,
no, I don't think so. Because I mean, a lot of people use, for example, like the Ethereum wallet, so Mist, and
we're not actually a node. It's just
it runs a full node, but they're just logging on to Mist to send a quick transaction and they shut it down.
So it's not full-time nodes. They're just like just-in-time nodes, kind of.
Right. But I would say that 7,000.
Africa, are you even trying? Like, what are they doing over there?
Yeah, I get what 7,700 nodes is actually not a small number. I mean, I don't know the number of Bitcoin nodes off the top of my head, but that network is, the value of that network is
10.
Hypothetically 10 times the value of the Ethereum network. They certainly don't have 10 times the
number of nodes. All right. So now I'm on the testnet, right? Like allegedly.
Well, you're downloading the testnet blockchain, but yeah, you are. Once your node is synced, then it will be relaying transactions and stuff. Yeah.
So, okay. And then I would basically go through the entire same thing we did, only just changing that configuration in Truffle.
Right. So, the idea is Truffle's trying to make it, I mean, from my understanding, Truffle's trying to make it really easy for you to set up your contracts, all the scripts you need to deploy them, and then, deploy them on your TestRPC or the test network.
Yeah, so then I just do the exact same thing for the Ethereum. I just run Geth normally. Now I'm an Ethereum node on the real network, and then I just deploy my contract, and I've done it. I've deployed. And in theory, I just need to have Ethereum in the address that I'm deploying from in order to deploy it, because that costs money.
Yeah.
Like if there was no Ether in the address. Yeah.
Ether, right. Yes.
All right. Wow. Okay. So that's really it. Like I think that's the flow. Well, what else? What else is there?
A lot. Yeah, there's a lot more.
So then what's the next point of complexity that I'm going to run into as we keep going? Is it just like the data structures you can use in the design patterns of smart contracts? That's really where it is, or is it in?
Well, I think it really depends.
Or is it in the UIs around these dApps? Like what have you been working on? What have you been spending most of your time working on?
So I've been trying to figure out what is like the most efficient way of having a bunch of smart contracts that interact with each other, but you want to separate them as much as possible so they don't rely on each other.
So it's like distributed system kind of thinking.
Yeah.
Like the way you would do it for any distributed system.
Yeah.
Yeah, gotcha. So it's really just like it's not any different than like building just a normal data system, only you're just doing it on the blockchain.
Yeah,
just
it really depends.
Same thing. It's just like data flow and all that kind of stuff. It's regular programming. Like it's not so different than regular programming. It's just on the blockchain.
Yeah.
Cool. All right. Yeah. Anything else you can think of that you think is? I think that's a pretty good 101.
Um, I think it would be really good, you know, to go through. People can do it offline. Go through the standard token contract, because
Just the code base of it.
yeah, it's a great example. It's highly audited, and it's probably going to be a component of many different systems that are built on Ethereum. So, yeah.
Awesome. Cool, man. Well, I appreciate you coming here and giving me all that information. And I hope when we upload this to YouTube, other people will find value from it.
Cool.
Cool, man. All right, sweet. Thanks. Peace.